So if you have a thyroid issue, you don't just get a sore neck.
Right, yeah.
The human endocrine system is this wildly complex web. So a tiny gland in your throat goes out of whack, and suddenly your heart rate spikes.
Hmm.
Your body temperature swings, you can't sleep, and your digestion just, shuts down.
Yeah, it cascades.
Exactly. You're treating a systemic fever, but if a doctor only looks at your lungs, they're going to miss the actual problem entirely.
Because the body doesn't operate in isolated departments.
Right.
Every system is constantly sending feedback to every other system. So treating one symptom in a vacuum, it can easily trigger a collapse somewhere else.
And the Earth operates the exact same way, which, we have a habit of trying to treat planetary issues in total isolation.
We do, very much so.
But our mission for today's deep dive is to look at the whole patient, essentially. We are unpacking the planetary boundaries framework. And we are using the foundational 2009 research by Johan Rockström and his colleagues, alongside the incredibly sobering new data from the 2025 Planetary Health Check.
Yeah, it is the ultimate diagnostic chart for the Earth system.
Okay, I like that.
The framework maps out the physical, chemical, and the biological processes that keep the planet habitable.
Yeah.
And it measures exactly how much pressure we are putting on those specific systems.
Right. And I want to frame this around something highly practical for the listener, because when we talk about global environmental health, it's really tempting to think of it as, I don't know, a charity project for nature.
Right, like saving a specific rainforest.
Yeah, or a charismatic endangered animal.
Or something, yeah.
Exactly. But consider the price of your morning coffee, or why the insurance premium on your house just doubled.
Yes.
Our global supply chains, our real estate values, our agriculture, all of it relies on the assumption that the weather, the oceans, and the soil will behave normally. So our entire civilization is basically a massive gamble on ecological stability.
It is. And it's a gamble we've been winning for a very long time thanks to a period called the Holocene.
The Holocene.
This is the geological epoch that began about 11,700 years ago, coming out of the last major ice age.
Okay.
And the defining characteristic of the Holocene is that its climate has been remarkably stable. The amount of carbon dioxide in the atmosphere hovered consistently around 280 parts per million.
For 11,000 years.
For 11,000 years, basically.
Wow. Which created predictable seasons.
Exactly.
And predictable seasons is the only reason human beings figured out agriculture.
Right.
Crops are essentially biological algorithms,
That's a good way to put it.
They need precise inputs of rain and temperature at exact times. So we couldn't have built permanent settlements, let alone complex global economies, without that 11,000-year streak of stable Holocene conditions.
We really couldn't. Every piece of human infrastructure we have today was designed for a Holocene world.
Yeah.
But the defining scientific reality of our time is that we are no longer in the Holocene. We have pushed the planet into the Anthropocene.
The Anthropocene, the era where human activity is the dominant physical force on the planet.
Exactly. From industrial agriculture altering the nitrogen cycle, to fossil fuels fundamentally changing the atmosphere, to urbanization just transforming the land surface.
It's everywhere.
It is. And what's fascinating here is how this shift completely rewrites the scientific playbook.
How so?
Well, in the past, environmental science basically asked, how much pollution can we dump into a river before it's completely toxic?
Right, it was very localized.
Yes, it was about measuring local damage. Now, the fundamental question is, how much pressure can humanity exert on the entire Earth system while keeping the planet within a resilient, safe operating range?
Okay, let's unpack this, because the language we use really matters here. When I hear the term boundary, or I read that a planetary boundary has been transgressed, I instantly picture, Wile E. Coyote running past the edge of the cliff. You know what I mean? It sounds like an immediate point of no return where we're just suspended in midair waiting for gravity to take over and pull us down.
That's such a common misconception. The Wile E. Coyote visual is actually a great way to explain what a boundary is not.
Oh, really? Okay.
Yeah, a planetary boundary is not the cliff edge itself.
Okay.
The actual cliff is what scientists call a tipping point.
A tipping point, like the ice albedo feedback loop.
Precisely. If the planet warms enough, reflective white sea ice melts, right?
Right. And that exposes the dark ocean water underneath.
Exactly. And that dark water absorbs more of the sun's heat, which warms the ocean further, melting even more ice.
Oh, wow.
Yeah, it's a self-reinforcing loop.
Right.
So once you hit that tipping point, the cliff edge, the system shifts into a new state.
And we can't stop it.
Right. Human intervention can't easily stop it. The system just takes over.
So a boundary is placed before the tipping point.
Yes. It's a scientifically defined risk management guardrail.
A guardrail. Okay.
Think of it like your blood pressure. If your doctor tells you your blood pressure has crossed into a dangerous threshold, you haven't instantly had a heart attack in the waiting room.
Right.
You haven't fallen off the cliff. But you have left the safe operating space for your cardiovascular system.
Oh, I see.
The risk of a catastrophic event has skyrocketed. And it is a massive, flashing warning light to change your behavior before the system actually fails.
That makes so much sense. So if these boundaries are the vital signs on the patient's chart, we should probably look at what's actually being measured.
We should.
The framework breaks the Earth system down into 9 major processes.
Yes, 9.
Okay, let me see if I can get these. We have climate change, land system change, freshwater change, atmospheric aerosol loading, which is particulate pollution.
Correct.
There's stratospheric ozone depletion, novel entities, biogeochemical flows, ocean acidification, and biosphere integrity. Did I get them all?
You nailed it. And biosphere integrity is a particularly vital one to understand because it's often oversimplified in the media as just biodiversity or species loss.
Yeah, like saving the pandas.
Right. But it's really the Earth's immune system.
Oh, interesting.
It encompasses the genetic diversity of the planet, which provides resilience against shocks. It's not just about losing large mammals.
Right.
It's about the loss of microscopic soil fungi that fix nutrients, or the pollinator networks that sustain entire regional food webs.
Which makes the findings of the 2025 Planetary Health Check all the more staggering.
It really does.
Because out of those 9 boundaries, 7 are currently transgressed.
7, yeah.
We have pushed 7 of the Earth's vital signs out of the safe operating space. And the newest boundary to officially be crossed is ocean acidification.
Yeah, and ocean acidification is a perfect example of how these pressures work physically.
How so?
Well, as we pump more carbon dioxide into the atmosphere, the ocean actually absorbs about 1/4 of it.
Okay.
That CO2 reacts with seawater to form carbonic acid.
Which lowers the pH.
Exactly. It lowers the ocean's pH. It literally changes the chemistry of the water, binding up the carbonate ions that corals and shellfish need to build their skeletons.
Wow. Here's where it gets really interesting to me because going back to our endocrine system analogy, we have this habit of isolating our problems. We host a climate conference in one city and a biodiversity summit in another.
Right.
But you can't just treat the ocean's pH in a vacuum.
You really can't. The framework forces us to realize that the Earth does not have separate departments.
Right.
And this raises an important question about how our mitigation strategies interact with each other.
Like unintended consequences.
Yes. For example, if you try to solve the climate issue by planting millions of acres of a single fast-growing tree species, you might be sequestering carbon, sure,
Okay.
but you're creating a biological desert.
Oh, because it's just one type of tree.
Exactly. You're trading climate mitigation for a massive blow to biosphere integrity and local freshwater cycles.
Wait, I'm trying to picture this compounding effect in reverse. Like, instead of planting, let's look at destruction.
Okay, let's do it.
If a nation decides to clear a massive tract of old-growth forest to make way for agriculture, they're obviously hitting the land system change boundary.
Yes, very directly.
They are physically altering the surface of the Earth. But that one decision doesn't stop there.
Far from it. The immediate secondary effect is on the climate change boundary.
Because of the carbon.
Right. You've removed the carbon sink, and burning or rotting those trees releases massive amounts of CO2.
And fewer trees means you are shutting down the biological pumps that move water from the soil back into the atmosphere.
Yes.
The trees stop sweating, essentially.
That's a great way to put it.
So local rainfall patterns shift, which hits the freshwater change boundary. You're drying out the whole region.
Simultaneously, you've leveled an intricate habitat. The genetic library of that forest is gone, degrading biosphere integrity. And to sustain the new agriculture on soil that was meant to support a forest, industrial farming will dump synthetic nitrogen and phosphorus fertilizers onto the land.
Which washes into the rivers and creates dead zones in the ocean.
Exactly.
That's the biogeochemical flows boundary.
You got it. You've hit 5 distinct planetary boundaries with one regional economic decision.
5 of them. Just from clearing some trees.
And that's before factoring in the synthetic pesticides applied to those crops, which pushes the novel entity's boundary.
Man.
The entire system cascades. Feedbacks are the invisible architecture of the Earth system.
So what does this all mean for us? I mean, when someone hears that 7 of the 9 boundaries are transgressed and that one economic action can trigger a cascade of ecological failure, the natural response is paralysis.
It is. People get overwhelmed.
It sounds like the framework is delivering an ultimatum, like halt all human development, stop economic growth entirely, or face total collapse.
And it's crucial to debunk that entirely.
Okay, good.
The authors of the framework are very clear that planetary boundaries are not limits to development.
They're not.
No. This is not a mandate for humanity to return to the Stone Age. The objective is development within a safe operating space.
But the framework itself has evolved to acknowledge that physical safety isn't enough, right? Like, the concept has expanded to the safe and just operating space.
Yes, the just component is essential. You could theoretically have a global society that stays perfectly within the 9 biophysical boundaries, but achieves that equilibrium through dystopian inequality.
Right.
A world where a tiny fraction of the population hoards all the resources while billions live in crushing poverty might be ecologically safe, but it is entirely unjust and morally bankrupt.
So sustainability isn't just about preserving trees, it's about preserving human dignity.
Exactly.
You have to decouple human well-being from environmental destruction. We need circular economies, vastly different energy grids, regenerative agriculture. It's an engineering and policy challenge, not a dead end.
It's totally an engineering challenge. And we know this kind of systemic course correction is possible because we've done it before.
We have.
Yeah. If we connect this to the bigger picture, we have to talk about stratospheric ozone depletion.
Oh, wow. The ultimate 1980s environmental villain, the ozone hole.
Yes.
I mean, it was the existential terror of a whole generation. We were all terrified of our hairspray.
With absolute justification. The ozone layer is Earth's natural sunscreen.
Right.
It filters out lethal ultraviolet radiation from the sun. And in the late 20th century, we were manufacturing chlorofluorocarbons, CFCs, for our refrigerators, our air conditioners, and aerosol cans.
The hairspray.
Exactly. And these molecules were drifting up into the stratosphere, and ultraviolet light was breaking them down, releasing chlorine atoms.
Okay.
A single chlorine atom can rip apart over 100,000 ozone molecules before it's removed from the stratosphere.
100,000 to 1. The physics of that are terrifying.
It's staggering.
We were systematically dismantling the chemical shield that allows terrestrial life to exist. I mean, we pushed that boundary deep into the red zone.
We did, but we didn't stay there.
We didn't.
The scientific community identified the mechanism. That data triggered unprecedented international cooperation, resulting in the 1987 Montreal Protocol.
Right.
The world agreed to aggressively phase out CFCs.
It's the perfect proof of concept. The science diagnosed the problem, global policy forced a shift, and industry responded by inventing new refrigerants that didn't destroy ozone.
Exactly.
And the result, the stratospheric ozone boundary is one of the 2 boundaries currently sitting comfortably in the safe operating space.
Yes.
The ozone hole is healing. It proves that a transgressed boundary is not necessarily a death sentence if we act systemically.
The Montreal Protocol is the gold standard for Earth system governance.
Yeah.
Now, transitioning away from a specific class of industrial refrigerants is mechanically simpler than unwinding our entire fossil fuel-based energy system to solve climate change.
Sure.
But the ozone success proves that global-scale environmental mobilization actually works.
It's possible, but there's a risk in only looking at global averages, isn't there?
What do you mean?
Well, a global boundary tells us the whole planet's vital signs, but it can kind of mask acute local crises. Like the global freshwater metric might look technically safe on a spreadsheet, while an entire subcontinent is facing a catastrophic drought.
Oh, absolutely, which is why the translation from global boundaries to regional action is so vital.
Okay.
The source material uses India as a fascinating case study for this exact tension.
Why India?
India is a nexus of explosive population growth, rapid economic development, and profound vulnerability to Earth system changes.
Right, the pressures compound so heavily there.
Yeah.
They're dealing with extreme heat waves driven by global climate change, massive urban expansion driving land system change, and severe groundwater depletion.
Yeah, but the most striking example of systemic feedback in India relates to atmospheric aerosol loading.
The air pollution boundary.
Right. Indian cities face some of the highest concentrations of particulate matter in the world.
Yeah.
Locally, it's a devastating public health crisis for human lungs. But functionally, it's an Earth system crisis.
How does smog alter the Earth system on a macro scale?
It comes down to thermodynamics.
Thermodynamics, okay.
That thick layer of aerosol pollution actually reflects incoming sunlight back into space.
Oh, wow. So it blocks the sun.
It creates a cooling effect over the Indian landmass. Now, the Indian monsoon, the massive seasonal rain system that sustains agriculture for over 1 billion people, is entirely driven by a thermal engine.
A thermal engine.
It requires a massive temperature difference between the hot landmass of the subcontinent and the cooler Indian Ocean.
Because hot air rises over the land, creating a low-pressure vacuum that sucks in the moist air from the ocean.
Exactly. But because the aerosol pollution is cooling the land surface, that temperature gradient weakens.
Oh, wait.
The thermal engine stalls out. The air pollution is literally disrupting the monsoon rains.
That is the ultimate aha moment for systems thinking.
It really is.
You think you're looking at a local smog problem, and you're actually looking at a disrupted regional water cycle? You cannot separate public health from the climate, from agriculture, from economics.
You can't. It demands an approach focused entirely on resilience.
Resilience.
Resilience is the capacity of a system, whether it's a forest, a city, or a global economy, to absorb a shock and still maintain its core functions.
Right.
Our goal isn't to micromanage nature. The core philosophy of this framework is Earth system stewardship. We have to manage the pressures we exert so that the Earth's natural resilience can do its job.
So bringing all these threads together, we've looked at an Earth system completely transformed by the Anthropocene. We've seen that our vital signs are flashing red, with 7 of 9 boundaries transgressed.
Yeah.
We've traced the terrifying speed at which an action like deforestation cascades through the climate, the water cycle, and biodiversity. But we've also seen the blueprint for survival in the Montreal Protocol.
We have.
The guardrails are scientifically visible. The path to a safe and just operating space is a matter of collective will and systemic engineering.
We possess the diagnostic tools. The X-ray isn't murky anymore, it's incredibly sharp. The question is simply whether humanity will act on the diagnosis.
Which brings me to a final thought I want to leave everyone with.
Okay.
Throughout this entire deep dive, we've been looking down at the soil, the oceans, the atmosphere. We've mapped out 9 boundaries that govern the physical Earth. But consider how rapidly technology is expanding our footprint, and ask yourself, is the framework missing a boundary right above our heads?
You're talking about the orbital environment.
Exactly. Think about space debris. In the last decade, we have launched tens of thousands of satellites into low Earth orbit.
We really have.
We are treating the space immediately surrounding our planet the same way we treated the oceans in the 20th century.
As an infinite dumping ground.
Exactly. But low Earth orbit has a finite carrying capacity.
The Kessler syndrome.
Right. The theoretical tipping point where the density of objects in orbit is high enough that a single collision generates a cloud of shrapnel, which destroys other satellites, creating more shrapnel.
In an unstoppable chain reaction.
Exactly. If we cross that unclassified boundary, we lose global communications, GPS, and ironically, the very Earth observation satellites we desperately need to monitor the other 9 planetary boundaries.
Wow.
It's a profound reminder that humanity's pressure on this system doesn't stop at the stratosphere. We are constantly generating new risks, and staying in the safe operating space means our foresight has to expand just as fast as our footprint.